If you get this question right, then you should just take your MCAT tomorrow.
The external auditory canal resembles a closed-end organ pipe. A typical canal is 2.5 centimeters long. What is the fundamental frequency? There's two types of pipes that we learn about. One is open-end and the other is closed-end, which is the one in the question. And basically open-end, as the name suggests, it's going to be open on both ends. You're going to have like your wavelengths kind of, look something like this. And then for closed-end, it's going to be closed on one end. And then your wavelengths are going to be something like that, right? These are like the different waves. You don't have to know too much about this, but it's kind of like a visual explanation. So the thing is, for open end, the wavelength at different harmonics is 2L over N, and for closed end, it's 4L over N, and N can only be odd numbers like 1, 3, 5, 7, etc. For this one, it can be 1, 2, 3, 4, it can be anything. And so anyways, we're dealing with closed end, so I'm gonna get rid of this open end. And now, this is talking about fundamental frequency. Fundamental frequency refers to the frequency at the first harmonic, so N equals 1. So what we really have here is wavelength equals 4L, right? And frequency, to get it from wavelength, you have to know the formula, which is going to be frequency equals velocity of sound or speed of sound over wavelength. So what we really have here is velocity over 4L. And velocity, this is just going to be the speed of sound in air, which is 343 meters per second, but I'm just going to round it to 340. So we have 340 over 4 times the length. The length is 2.5 centimeters. 2.5 centimeters is the same thing as 0.025 meters. So we're going to put 0.025 meters here because this is meters per second, so we want meters to cancel out, right? So anyways, when we do this, we're gonna get 340 over 0.1, and then this will just be 3,400 hertz, right? Hertz is the same thing as inverse second, so this is hertz, right? And our answers are in kilohertz, so we just divide by 10 to the 3, we get 3.4 kilohertz, which is answer choice C.